Hello, everyone. Welcome to the NANDA Summit on May 30th, 2025. NANDA stands for Network AI Agents in Decentralized Architecture. Today, we are doing a deep dive on 2 big projects, as well as 5 new papers, as well as demos and code for the Registry quilt that's created by NANDA and extended team. I'm Ramesh Raskar, professor at MIT. And we really want you to imagine the world of billions, maybe trillions of AI agents that are communicating across organization silos, navigating, socializing, learning, earning, and transacting on our behalf. Today, we'll have Mr. Guha from Microsoft talking about NL Web. Then we'll have Sam Sharaf from Salesforce about his ideas on the Agentic Web. And then we'll have 5 blockbuster papers from the NANDA and extended team about why you may have to switch from a DNS model, how will the quilt of registry will support MCP, A2A, NL Web, Web3, even IoT, comparison of different registry approaches, the security layer, and how the fact that these agents will move to the edge with TinyML will change everything. And then we'll end with demos of this. So to make this registry very neutral, we have 15 partners, 15 AI universities across the world holding this quilt of registry. And you can also go to nanda.mit.edu to look at all the code, GitHub, papers, servers, clients, and contributions from various partners. As you can see, we're delighted to have many of these as partners, funders, co-authors. So the work you're seeing today is from a very large collective. And this is a mental model we want to keep you in mind, which is, platforms like A2A allow agents to talk to each other. MCP allows agents to talk to tools, but we still need a phone book. We still need a directory. We still need a quilt so that agents can discover, authenticate, and handshake with each other. But within that, we think the Agentic Web have about 7 different choke points. And the goal for the NANDA Collective is to go and solve each of them over time with our partners. So you'll hear about them today one by one. There's a one key distinction I want to kind of highlight between how a lot of other organizations are thinking about agents, usually in enterprise settings, versus how we're thinking about it. One is that we think they're dynamic. They'll be edge aware. So they'll be running on smaller devices like laptops, phones, cars, drones, and so on. And because of that, their endpoints are changing all the time. And a lot of this will be consumer driven, where you have billions, maybe trillions agents that are out there. And it's bidirectional communication, which is not that my agent can call an agent outside my organizational boundary, but somebody outside the organizational boundary can call me, call my laptop, an agent that's running on my laptop. So I think there are 2 ways to go for this. One is a centralized registry, like it's done with DNS today. The second approach would be kind of a decentralized registry, where every website maintains the list of the agents that they're running. And both of them have pluses and minuses. With the second approach, decentralized approach, there is a major risk of re-centralization, where 1 or 2 entities could scrape all this agent list, aggregate, and serve those queries. And that re-centralization could lead to gatekeeping, bias prioritization, and censorship as well. So there are pluses and minuses to both. And I think the NANDA quilt approach is a hybrid approach where anybody can maintain their local decentralized registry, but there's a lightweight central index that routes the relevant local registries to avoid full centralization. And the metadata is not kept on the main registry, but it's off this registry. So we'll be talking about this in 5 papers that are coming up. And again, the goal is to really support every type of resource, tool, MCP server, NL Web, AI agents, agent stores, IoT, Web3, and users themselves. So you'll see a lot about that today. And kind of an example scenario would be, a doctor in Houston can use this kind of a command or a query, if you want to call it, saying, I'm Dr. John, I want to help patient Sarah, look up her health records, here's my payment wallet, here's my compute agent, here's my hospital router, and please use Tableau to bring back the visualization to me and to my patient. And we think all of this will be possible. We'll be showing you a demo at the end of today as well. So with that, let me hand it over to Dr. Guha from Microsoft, tech fellow. He's been at Netscape, Google, OpenAI, and more recently at Microsoft. And his project on NL Web is, we are a big fans because I think MCP allowed us to convert any API into an agent. And NL Web's mission is to convert any website also in an agent. So over to you, Dr. Guha.
Thank you, Nanda. Thank you for having me. So let me try and set the context of what we are doing here at Microsoft. The idea is we've been through sort of three revolutions in personal computing. First was the introduction of GUIs. The second was the introduction of internet, and more recently, mobile. The idea of being able to converse with any application, any website in natural language is a very old one. Unfortunately, the technologies required for that were not quite there. Um, when ChatGPT showed up on the scene about 2.5 years ago, a lot of us assumed that in fairly short order, that is how we would be interacting with most websites. Unfortunately, it turned out that there were whole layers that are missing, and we haven't yet seen that kind of a revolution. NLWeb is an initiative from Microsoft. Everything that you're seeing here today is actually live. A bunch of the sites that you're going to be seeing are going to be going to go live to the public in the next few weeks. Everything is open source, and what we are trying to do is to let me just show you a few demos. Imagine that you go to there's a recipe site called CDS Eats. It's quite popular. Imagine you go to it, and instead of searching around and clicking around there, you can start doing things like give me recipes for spicy, crunchy snacks that I can serve as an appetizer at a party. And that it goes, and it gives me back answers. A few interesting things. One is every one of the items that is received returned is actually an item on their site, so there's a fairly hard guarantee of no hallucination. The second point is that this is not just search; it's a real conversation. This is for a Diwali party. And so it can understand what Diwali means. It brings in knowledge about Diwali, and you get Indianish stuff, chart and save and puppies and things like that. And as I go down here, I notice that some of these items over here are, loaded nachos with ground lamb. Well, I'm vegetarian. Um, 25 years after the web or 30 years after the web, it still doesn't remember that I'm vegetarian. This one over here understands that I am vegetarian, and then does the right things based on that. Um, what is underlying here is not just, and then I get, of course, the only vegetarian recipes and so on. The we Not everybody needs to wants to have this kind of a UI. Some people would like to have more conventional UI because their business model depends on it, and so on. And so here is a side backcountry, give me jackets that I could use to go hike, hiking in Yosemite in December. And this not only gives me it brings to knowledge about December and the weather in Yosemite and so on and so forth, but also allows the website to have a more traditional UI so that they can continue with their sponsored links and other such things. Underneath here is there's let me give you another example over here with let's actually go back to the backcountry example. Um, And what comes back over here is it's getting slower and slower, and it is a set of JavaScript objects. So one way to think of it is that MCP is like HTTP. It provides a transport. It allows a site to expose its methods, but an agent still needs to know exactly how to invoke the methods on every single site. Imagine one of the special methods a site NCP also sort of is targeted at you have a central intelligence, a chatbot, which can then reach out through these methods into these other tools, if you will. Our model over here is to try and distribute the intelligence so that you have every website, every application can become intelligent by itself and has agency and can negotiate and deal with other agents on an equal basis. Very much in the spirit of Ramesh's Nanda. And for that, we need, on top of the HTTP, we need an HTML-like layer, one which actually specifies what the payload is. So in this case, the payload, the query that comes in is natural language queries. And the thing that comes out is a structured form, which includes, in this case, things like the actual schema.org object that each of these things corresponds to. This is just the beginning over here. We are, it's not only is it open source. There's two different things about NLWeb. One is the set of the protocols that we are trying to figure out how to standardize, much along the lines of how we did it with schema.org. And the second one is an actual implementation that people can take and start playing with, and so on and so forth. With that, I think I'm 12 minutes off of 15, so I'll take any questions if there are.
That's fantastic, Guhak. Maybe you want to talk a little bit more about why this mechanism will make it easier and the role of RSS and schema.org.
Sure, absolutely.
And if you had the luxury of, I know you're the inventor of these things, if you had a luxury of inventing one more thing that will make the web even more compatible with AI agents, what would that look like?
Sure. One of the big goals that uh, if you look back at 94, 95 in the web, there was this thing called a homepage. Everybody had a homepage, and people looked at a homepage and said, "I want one of those." Right? We have a lot of excitement about AI, but still, you can go, unless you go to one of the four big AI portals, you could spend an entire day or entire week, and many people actually, believe it or not, spend an entire month without encountering an AI. At the same time, there is a huge opportunity for improvement in the way in which we navigate uh, sort of the space of information on the web. And so the idea is if we could, the way this thing is powered is the following, which is if you take a look at one of these recipes over here, it looks like a normal site. But underneath here, what we have is, if you look at it in the schema viewer, all of these sites, roughly 50% of the pages in the major search indices now have this markup called schema.org, which is a semi-structured markup. And it also turns out that the LLMs understand this markup language incredibly well because they've been trained on it. So leveraging that, we make it utterly trivial. In a matter of, one of our partners, TripAdvisor, saw the first, got access to the GitHub repo on a Tuesday, and by Thursday they had a version up and running. And we can make it, as tooling develops, we can make it even shorter. Now, the part of the reason why we made everything open source is because we need the investment of sort of hundreds of thousands, if not more, developers to take this forward. I see this a lot like how the web was in January of 95. There were only tables, there was no JavaScript, there was no CSS, there was no nothing. And yet collectively together, everything got developed and the same ideas over here.
So do you see a future where this is almost a bridge, right? Today we are creating a website, and then from the website, we are going to an AI agent.
Yes.
Much like previously we would create websites and then created a mobile experience separately from that. Do you think
Yes.
the order will reverse and we will create agentic websites first before worrying about creating human readable websites?
There's two parts of it. One is what does it mean to be a website might itself change. So we were having a conversation with some senior people from TripAdvisor, and the point was that I need some, when you're taking a trip, um, you want something to come along with you which knows everything. And this unit called a web page is a very convenient unit. Before this unit showed up, we had an internet that had Usenet, and then we had other things, and we in that unit of a web page with links to navigate around and drop down menus and so on did good for about 30 years. It's time to move on further. So I think the idea you will have, whether you call it an agent which you talk to, whether other agents talk to, etc., is going to be different. It's going to be an endpoint which is going to support communication, which is much more friendly to human beings.
Mhm.
And I don't, yeah, this whole thing is a transition. uh, NLWeb is a transitionary thing, but like many other things, it may not be just. It may just stick around. One hopes. We'll see.
Yeah, let me ask a related question. I know more questions are coming up in the chat. Please feel free to type them in the chat, and I'll try to take some of them for Dr. Guha. Uh, as we discussed in our prep call, Guha, I think there are very few projects that are thinking about consumerization of AI agents or agentic web, and this may be one of the prime examples. Project Nanda, of course, is thinking about consumerization as well. How do you see that playing out, the consumerization aspect of it versus enterprise? Of course, a lot of your work requires enterprises to change their websites to do this, but hopefully anybody can, when they create their website on Wix or Squarespace, can have this as a plugin. How do you see this playing out, enterprise versus consumerization, and overall overview on agentic web being consumer first or enterprise first?
Um, I think it's going to depend. There are some technologies like the adoption of PCs was enterprise first. The adoption of the internet of the web was consumer first, and traditionally consumer uptakes have been the consumer world on the web is very, very different. The economics are different, and the marketplace is different. I think you need to show people we're in an interesting position where a lot of the consumer websites are concerned about being disintermediated. If we can, and there's an interesting opportunity where if we can give them a value proposition where it doesn't take much effort for them to put this up, right? And they have to see returns. Um, I see a question about from Raghu Bala about concept of semantic web, etc. Well, guess what? It might not have been called semantic web, but schema.org is driven by all of that stuff, right? And schema.org is now there on 50% of the web pages. I can pull up a random page on Walmart or anywhere, it's there. And the key is that if you tell people they should do something because it is a good thing for the world and this is a grand vision, etc., they won't. If you give them something where they get some return immediately, they will. And the idea here is that um, if Serious Eats or an All Recipes or a TripAdvisor and an Eventbrite can see immediate value for their users for a very low investment, they are very likely to do it. And we have to find that path of incremental slope where it's interesting. It also needs to be permissionless, which is that they shouldn't have to do a deal with a chat GPT or a Gemini or a Perplexity in order to get their content, in order to have this functionality. It should just be without. There was a demo from the Stanford, some bunch of Stanford kids who built an interface like this for Stanford's Explore, which is how you find courses on Stanford. And so that is the kind of thing that should be possible very easily, and then it'll take off. Yeah.
Yeah, yeah. So I don't think we got to the question of the enterprise first
I don't know the
aspect of it.
answer. I think there's an enormous amount of investment in the enterprise context.
Right,
One of the things that agents do incredibly well is to help people navigate complexity, and enterprise applications have become kind of complicated.
right.
And On the other hand, enterprise adoption tends to be on a slightly slower pace because it's bigger enterprises. It goes through the IT department and so on. So it's going to be an interesting. I don't have an opinion of. I don't know which one it's going to be. My personal experiences have been completely on the consumer side, and so I'm driving it from consumer applications. Yeah.
Yeah. I know the Nanda community has a lot of innovators, a lot of entrepreneurs,
Yeah, would
a lot
love
of
to.
investors here. What would you say to them? Should they bet their farm on NL Web?
They
And
should not bet their farm on anything. I never bet my farm on anything. But the point is, how can we reduce the cost of the bet, right? So that it's not betting a farm, but much smaller investment, go to the GitHub repo, download it, see what you can build today. There's simple adapters. There's a hello world thing there where you can point it at a bunch of RSS feeds, and it'll learn that, and then you can ask it questions, and you can do things, and and stuff like that. It should be fun. Put it up there on a website. The cost has been optimized. You can use it with any vector store. It comes with a few vector stores. You can use it with any model. You can run it anywhere. I can run it on my laptop, and so it's cheap. It's easy. It gives you something to show off. It's your new the 2025 version of, look, I have a homepage.
Yeah. Let me take a few questions from the chat here. We have almost 100 people online now from different time zones. I think there's some questions about how will this play with MCP, and I'm going to add to that question about A2A, things like this, lightweight indexes like NANDA Quilt Registry. Just share with us kind of your thought process there.
The MCP story is very, MCP is at a, in the stack, MCP is at a lower level in the stack. It's MCP is a lot like HTTP. MCP basically goes and enables the server to say, here are my methods, and here are their signatures. It doesn't assume that the thing that is exposing the MCP endpoint is actually intelligent. NLWeb goes on top of that. NLWeb says, let me actually put some intelligence there so that MCP puts all the load of figuring out what methods to call and so on the caller. Over here, this goes at a higher level and says, I'll figure it out. Just ask me natural language. And I'll give you back my responses in a standard form so that you can aggregate them, and you can do all kinds of things with them, and so on and so forth. There are things that are coming into the NLWeb layer, like if I give you my content, can you please use it this way to make sure that it is displayed this way, and here is a license with it, and here is how long you can keep it, and all of those kinds of things, which it's a lot like, as I think Kevin Scott put it very nicely in his talk at Build. MCP is like HTTP, NLWeb is like HTML, and if you look at the relative complexity of HTML versus HTTP, you can see that HTML evolved for many, many years after HTTP was essentially frozen. So that's and then also every NLWeb server comes with an MCP server, so you don't have to worry about that. So you put NLWeb, you're already in MCP. You're in the MCP world. Is NLWeb equals LLM plus MCP client? Yeah, it's a simplification. There's a bunch more stuff to it over there in terms of processing. I suggest you look at the I don't want to. I'm very suspicious of one-liners. Yeah.
And so talk a little bit more about.
This is a really interesting point, which is we're going to require things like NANDA, which know who to ask what question, right? And the question is, if you have, there's about 50 to 100 million sites which support schema.org, and in very short order, they can all become NLWeb endpoints. And when you create an NLWeb, what you get is an agentic endpoint, which exports a single method, which is ask, where you can, and then there's a couple more methods coming, which is like do, which takes a method and in natural language and gives you back a response. Now this endpoint and all the interfaces I showed you are just thin JavaScript layers that are talking to this endpoint. But it need not be JavaScript that a human being is interacting with, that is taps into this endpoint. It could be another program, another agent, which is tapping into this endpoint. And there could be a network of them doing interesting things, right? Now, the question is, in a world with 1 million of these things, we need a place to ask, look, I'm trying to get this thing shipped from Delhi to Kathmandu. Who can do this for me, right? And there will be a need for that. And that, I think the architecture of those beasts are going to be different from the architecture of what we think of as search engines. Search engines essentially make a copy of the web or the copy of whatever they are searching over of the corpus, and then essentially use different algorithms to search over them. This one is going to be different, which is it's going to have knowledge about the what each of these corpora contain and what those agents can answer, because those agents also will have knowledge about the world, about it, and hopefully some reasoning capabilities and so on. It's going to be fascinating to see where that develops.
Fantastic. I lost the last question, which is from it's from, let's see. It's from Akram Sharif, one of our co-authors at NANDA. And he's asking a very important question, which is kind of multi-turn agentic planning. And also the question you received from Maria yesterday from our team, which is the actions as opposed to queries. So if you
Yes.
can kind of share your thoughts on that.
There is a natural multi-turn conversational thing that is built in over here that I showed you when I said, it's for a Diwali party and so on and so forth. That's another big, it's not just a natural language. The bigger thing is actually memory and context. The web is, too many sites are stateless. It's like the movie 51st Dates. You go back there, they've completely forgotten what you've done. This takes it just out of the box. You get this experience where this thing has memory and state. Actions is much more a more involved topic. We're in the process of putting in actions, and actions meaning not just go buy something or go put something in a cart, which results in a state change, but the what is there in Endeavor today is the rough analog of htdocs stage of the web, where you could display static documents. One of the big innovations that happened was when Rob Mickle put in CGI bin, where you could execute arbitrary functions. Right? And in fact, most of the functions that are executed arbitrarily are to just don't have a side effect. But that mechanism to be able to invoke and execute arbitrary functions in response to a natural language um, uh, statement by a user is something that is going in the next week or two. And subscribe to the GitHub repo, and I'll sometime in the next day or two, we're going to put something over there about how what the thinking is, and the whole everything there is going to be iterate very, very, very fast. But I think once we get there, then we can actually see. I mean, the hope is to see a Cambrian explosion of agents, because you can now make it easy for somebody to put up something that is genuinely useful, not just a curiosity, across the board.
Yeah. Project Nanda and Microsoft NL Web are going to host some hackathons, virtual hackathons, in the coming days. And given both efforts have an ethos in thinking about consumerization and making it easy to deploy, we would love your comments, your participation. Follow the GitHub for NL Web, follow the GitHub for Project Nanda, and stay tuned for some more amazing features, more amazing capabilities. And Dr. Guha, I'm just curious what the developers on this call are going to go build with this
I'm very curious too. Yes. Thank
Thank
you
you
so
very
much.
much.
Thank you for having me. Goodbye.
Thank you. So we're just going to move on and talk a bit more about many of the opportunities in this space. If Mahesh, you're ready, we're going to come back to Samuel Sharaf because of some.
Oh, actually, Ramesh, I'm ready if you want me to go now.
Excellent. All right, fantastic. Then let me switch to your slides. Good timing.
Thank you, Ramesh, and hello, everyone. My name is Sam Sharaf. I'm a product lead with Salesforce Agentforce AI team. My responsibilities include basically leading the multi-agent initiative at Salesforce with Agentforce and how agents talk to each other, how they discover each other, register, and also the whole agent interoperability, which I was talking to Ramesh that, hey, 25 years ago, that was the age of internet, right? We were looking at how internet nodes, when a new computer is plugged in to the internet, how is going to be registered, how the MAC address is registered, how it is found on the web of network. And we are pretty much in the same era again with the agents. So if you, Ramesh, if you can go to the next slide. So I wrote this earlier this year, which is basically a white paper on 10 factors for agent interoperability system. So when we think of multi-agent systems, there are a lot of considerations because just making the agents talk to each other is in some ways a problem, but not the whole problem. So we need to take a step back and say like, hey, what are the key principles of agent interop? So one principle which I introduced was called agent metadata card, and that pretty much kind of analogous to the LLM card, which is like, hey, you go to Hugging Face or OpenAI and you look at the model, and the model basically describes as like, hey, this is my context window, this is how to use it and stuff. In the context of agent, I think it becomes important that we define what are the agent capabilities are, if that agent can handle PII, PCI data, is it a HIPAA compliant in the context of healthcare? And then going from, and in the context of agent registry, we'll index it more. And then we go into identity and authorization, right? So that becomes very important, is especially for cross-domain agents, which are across network domain. How do agents authorize with each other? How do they share identity? And is there a notion of role-based access control? And then very importantly, agent versioning, registry, and discovery, right? So as agents improve, we version them, right? And there is a centralized place similar to DNS registry for web. Are we also registering these agents and providing a good mechanism for discovering the agents? Agent-to-agent communication becomes important. Like I said before, that's at the core of it, is in a multi-agent system, how agents are able to communicate with each other. And then you can call it the agent orchestration engine or the gateway router. Different people are using different words, but there needs to be some mechanism where there is a concept of a router which is involved in also routing the requests when we are fast going towards the time of thousands to millions to maybe billions of agents, right? So how does the various routers across different systems working to orchestrate these agents? And then, of course, there's state and conversation management. How does agent orchestration works in the context of multimodal agents? So that becomes important as well. Observability, monitoring, and trust scores. So at Salesforce, trust is our number one value. So everything we do is basically underpinned by, number one, is it secure? Is it safe? Would the enterprises, the businesses who use us would trust us with that? So that becomes important. Security and compliance, of course, in regulated industries, that becomes important. And then lastly, what I call the non-functional requirements, right? Scalability, performance, latency, those become important. So let's move on to the next one. So like I said before, since we are talking about the agent registry, specifically in this topic, I'll index on a little bit on agent card. So this also made its way into the Google A2A protocol, which you probably already saw or heard. And so the key concept there is what are the key metadata fields in agent, which when we register it, it basically gets registered with those. So for example, unique agent ID, human readable name, who is the publisher? Is it Salesforce? Is it MIT? Is it Microsoft? What are the capabilities of the agents are, right? What jobs it can do, which can lead to like, hey, runtime discovery of agent. I'm looking for an agent which can do X, Y, and Z. And from there, the discovery service will help find it with its endpoints, what kind of trust score it has, and what kind of security requirements it fulfills. So all those become important. Next slide, please. All right, so when we go into agent registry and discovery, the key definition there is pretty simple, right? A centralized or distributed place where agents register capabilities, endpoints, versions, and metadata. And I think a key part of that is it should be able to handle dynamic updates when agents come online and offline. So the way we are designing at Salesforce is basically with the mindset of crawl, walk, run approach is have a registry with a notion of agent cards so that there's a standardized agent manifest, and that basically becomes compatible over time as the organization-wide and industry-wide adoption occurs, so that and there's going to be various registries, right? And it's great to see an initiative by Dr. Ramesh on NANDA. I think that would help propel this movement. But I think initially there will be a lot of individual organizational registries. And I think that's where it becomes also important is how these registries are able to communicate with each other that, hey, these are our agents which can talk to the other agents across domain. Can registries share that information across each other across domain? And that becomes so if you go to the next slide, Dr. Ramesh, there is a picture there which will help with some of the wording I'm mentioning here. So as you probably remember, DNS, right? DNS became famous 80s and 90s, right? So the concept was like, hey, a human readable name instead of like trying to remember the IP address of where this service is located, right? So it's very similar to the phone book of the web. So agent registry at the same time, and it's right now in this picture is a centralized agent registry, but um, even if you have distributed registry, it's the same concept as it's basically will become the directory of the agentic web, and it will have agents and not just registered agents, but identity. The registry should provide identity verification, some kind of trust score, like, hey, this is not a malicious agent, it's verified, it's trusted, it's secure. And like I said before, how the agents can be discovered through its capabilities, through its functions, and all that. Next slide, please. All right, so key points, just as DNS aligns humans and machines to the same naming system, a registry for the agentic web is critical for interop and trust. And as you can see, I've scaled the agents to many to illustrate the point is that, hey, number one is the agents are only going to grow, right? So discovery and registration services become more and more important. And then also, I think very crucial to that also is how these agents will be able to negotiate, right, transact and collaborate. One topic here also important is human in the loop. When does escalation occurs to human, both at a time of discovery as well as registration? Because initially, I think human in the loop will be really helpful to have some kind of intervention, especially when errors are arising. But over time, as we go from semi-autonomous to completely autonomous systems, these registries and the agentic web needs to mature to a point where it's more autonomous and automated. So I'll take a pause here, Ramesh, and see if folks have questions or comments.
Let's do that. This is amazing. Thank you, Sam, and wonderful to hear that you are the original designer of kind of the agent schema, agent card, agent facts. Many of the concepts that are coming together. It's kind of your passport that you're carrying with you beyond your phone number. So that's fantastic. One natural question here is, how would this evolve in organizations that are catering to its own clients? Salesforce is one of them. Microsoft has co-pilots. How would it happen? Kind of, let's call it the intranet of the agents versus the internet of agents. So the registries that are within an organization versus registries outside. And more importantly, when somebody wants to, it's easy to call from intranet outside, but when somebody from outside wants to call an agent that's inside the intranet, how would the registries play a role?
Yeah, great
It's
question.
one of the major thing on our mind at Nanda as we are working with you and many others in
Right.
designing the quilt of registries.
Yes, definitely. And great question. And something I probably didn't highlight. So at Salesforce, what we are doing actually is we are building, and I'll use your terminology, is intranet first. Because at Salesforce, we have, as most of you know, Service Cloud, Sales Cloud, Marketing Cloud, Commerce Cloud, and then we have industry clouds, right? So each of our clouds are building their own agents. So within our organization, we kind of have an intranet of agents. So our first problem actually is how do we make these agents talk to each other? And that's a big problem. So I pinged Dr. Ramesh earlier this morning, like, hey, I got into an urgent product call. And literally the discussion was this, like, hey, how are we, our very, very top level executives want to know, like, hey, how are we delivering for our own internal agentic use cases, right? How are we making the agents talk to each other? So that's problem number one, what we're calling customer zero. And then from there, we scale to like, hey, now we have solved this. Now let's also make that these agents, like our service agent, our marketing agent, it's also externally accessible. So in that context, going back to your Internet of Agents terminology, is can we start publishing these on our, let's say, agent exchange? And then let's say Google and Microsoft and Amazon, they can go to, their registries can go to connect with our agent exchange and figure out like, hey, here is a registry which has these standardized agents which can help interoperate with our agents.
Yeah, I'm taking the luxury of showing, the current mental model for this lightweight index, which we're calling the Nanda quilt, and it's really interesting to hear that it's happening in real time while you're on this web
Yes.
webinar call. You're getting called in from within Salesforce to deal with this interoperability issue and customer zero. Um, I'll ask the same question that I asked, Dr. Guha from Microsoft, which is consumerization of agent world versus kind of enterprise aspect of the agent world. And Dr. Guha is back, so we can have a lively conversation. What makes sense? If you look at the internet in the 80s, it was like IBM and DEC and Cray supercomputers and mostly mainframe companies actually sitting at Route 128 around Boston. And they lost the battle to companies that were thinking kind of consumer first, Bill and Steve's of the world, who said, hey, you know what, the PCs are going to actually build the network of tomorrow. And I think the momentum very quickly shifted away from Boston to Silicon Valley when it came to building the internet on the web, although the World Wide Web was being designed at MIT with Tim Berners-Lee. So I'll ask the same question to both of you.
I'm sorry, I have to protest.
Go ahead, Dr. Guha.
Here is my version of what happened.
All right.
The internet stood not for a single TCP/IP, but TCP/IP was supposed to be internetworking, which is why Cisco's logo is a bridge. And it actually had an uphill battle. There were proposals from IBM and others to have very, very different kind of networks. And in fact, IBM really fought it very hard. I think IBM was Token Ring, etc. The place where things changed was when, in response to the Japanese fifth generation project, the US did this, introduce its big supercomputer project where you had these 5 supercomputing centers in San Diego, Urbana-Champaign, and so on. And they decided that the way in which faculty could and universities could access these supercomputers was through a network that ran TCP/IP.
Mm-hmm.
That was the thing which made it really win. And then Wind's second big contribution was he introduced email over TCP/IP with POP, and then IMAP came along. In terms of the web itself, it was just fortunate that um, Jobs picked TCP/IP as the protocol, as the communication networking protocol for the next machines. And Tim BL, sitting in CERN, not at MIT, in CERN in Switzerland, had um, a next machine. And he had a project where you had these companies, researchers from different countries come with their own phone book directories. Okay. And he had to network all of these things together. And the justification for the first web browser and the web server was to integrate different phone books. And then Andreessen saw that in his Andreessen started off by trying to say, is there a web mode for Emacs? And then Eric Bina convinced him, no, 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 we need to do a whole new thing. And the reason why the particular set of widgets exists in HTML today is because that's what was there on his windowing system and Bina's windowing system in CSA And then Andreessen came to Silicon Valley, and Tim Beale and Mike Tertuzos convinced Tim Beale to come to MIT. Sorry.
Yeah, but I think no, it's fascinating, and it's definitely fascinating. But the examples you gave are all, I would say, kind of consumer facing. Email, or the fact that scientists can talk to each other and so on, is what really propel, as opposed to the other way around, saying, hey, I have a database and I just want my databases to talk to each other. So I just want to kind of add that subtle point that the scale came because there are millions, maybe billions of people online, and that's where all the innovations came. And because we have, as you said, HTTP and HTML that's used on the World Wide Web, the same systems also get used internally on the intranet. On the intranet, we don't go and say, let's use something other than HTTP because we are intranet. We say, let's use the public protocols also for intranet systems.
Yeah, look, it's going to be fascinating. I don't know how, and the reason I'm not saying that it's going to go consumer first or enterprise first is not because I have of I just don't know, and it's going to be utterly fascinating. So if PCs took off initially because of Lotus 123, and Lotus 123 was not used by consumers; it was used by people inside companies. The web took off actually in universities first, and then from there it spread everywhere. Where is it going to go? Enterprises tend to be much more tolerant of complexity, enormous amounts of complexity. Um, Consumers are not, and my personal I'm personally attracted towards reduction in complexity and increase in functionality while keeping complexity the same or lowering it. So I'm attracted towards the kinds of things I showed you. It's also just fascinating to have a sort of see ecosystems develop like that, right? I've been fortunate to have been part of a few of those, and just taking another big swing at it. So
Fantastic.
I mean, here is the way I phrase it. Here are the daily problems of that so many of us face, and then I don't want to call it problems given everything that's going on in the world, which is, what do I cook? Where do I eat? What do I stream? What do I listen to? And the answers that you have, and the things that you have, every family faces, like, what are we going to stream today? The interfaces are just not really rich enough. I want something that is far, far richer. And if I can do that, and if I can give it to everybody and have a million points, it would be fascinating.
Absolutely. Thank you, Dr. Goha. Thank you, Sam. We're going to move on with our program, and we're going to have bang, bang, bang. We're going to see 5 papers that are sharing with you how to think about this hybrid model of creating a lightweight index for this registry. And as we saw earlier, we have co-authors from many organizations. These folks are working day in and day out, late nights, weekends, trying to make progress in this field, being very inclusive, really great intelligent conversation. If you want to join us and write these documents, and you also see a lot of coders here. This is the GitHub that's very active. It already has a whole bunch of papers that are coming together. and so on. So we're going to go through each of these papers today in about 12 minutes at a very rapid pace. So feel free to look at that. We'll post these links in the chat as well. But yeah, I'm going to hand it over to Mahesh and Abhishek to talk about the first paper, which is why do we need to switch to a different DNS model, or do we need to switch to a different DNS model? With that, handing the screen over to Mahesh and Abhishek.
Okay, so let me share my screen. Yeah, 1 second. Would you mind sharing? I think we have a trouble sharing. Ramesh, I think we'll continue with that.
Okay.
I can share.
You can share? Okay, thank you. Thank you. All right, I know this is exciting because we heard so much, like from Dr. Guha and Dr. Ramesh, and this is exciting time, for all of us. Basically, we are way junior, because to witness another moment in the history that's happening in front of us. So thank you so much for all the insights. This is Mahesh. I'm part of the Project Nanda team. I'm a Stanford alumni and ex-Microsoft. So let me start with the moment that's been floating across every AI boardroom and developer Slack lately. The question, to MCP or not to MCP, A to A or not to A to A, or NL Web, or something beyond. So it's interesting how memes simplify what are actually deep architectural questions, because behind that lies a serious dilemma of AI agents are going to talk to each other across companies, clouds, and even continents. But how will they even find each other, verify each other, trust each other? We all want like smarter agents, better prompts, new benchmarks almost every other day. That the pace is super fast. But beneath it all, we need to pay attention to a most important foundational layer, a registry fabric. At Project Nanda, we have been diving deep into that foundation, researching the quilt of registries needed for Internet of AI agents to function at scale, securely and autonomously. Today, we'll walk you through the crossroads we are at. Should we upgrade our legacy web stack or to have completely new, like to meet agent era demands? To the next slide, please. Yeah. Okay, so this basically, so this is again, I'm too young to talk about this deja vu moment, but I believe Dr. Ramesh and Dr. Guha can correlate more than me. But this is kind of a deja vu moment, right? So the early internet ran on a dial-up limited to 56 kbps, circuit switched, built by the minute. It worked, like it was not a problem, but it barely worked. But as the web evolved, video, multiplayer gaming, cloud services, dial-up broke down. We needed a broadband, always on, packet switch, scalable. That shift didn't just unlock speed, it unlocked the possibility. So why bring this up in a talk about AI agents? Because history is repeating in a sense. Today's web infrastructure, DNS, IP addressing, TLS certificates, it was built for static websites and passive APIs, not trillions of autonomous AI agents making decisions, migrating, delegating, negotiating as if like a human being or a living thing. So like engineers who saw dial-up ceiling coming, we now see the cracks forming in our registry infrastructure. If we want to unleash the full potential of AI agents, we will need a registry fabric that's more like a fiber than a fax line. So the real question is, will we upgrade our current infrastructure, or do we switch entirely and build a new one for trillions of AI agents? So the next one, please. So here we are capturing like what's actually changing. So traditional web has been reactive. It waits. You or me as a consumer, like click a button and the server responds. The cycle ends right there. There is no memory, no intent, no initiative. But now we are entering the era of proactive agents. These agents are not just endpoints. They are long-lived, LLM-powered digital actors. They interpret user goals, retain memory across interactions, and initiate tasks on our behalf. So think of an AI travel agent that not only remembers your preferences, but negotiates it with airline bots on their own, rebooks your midair or reroutes ground transport, and all without waiting for your prompt. So the current web stack was never designed for this. It was built for human-triggered actions, but now the actors are software entities themselves. So with autonomy, initiative, and state, and that shift in agency changes everything. How we coordinate, how we secure, how we name, and how we govern these digital agents. So the next one, please. Yeah. So let's break down how this shift actually unfolds at the execution layer. Like first, it's a control. In the legacy web, control starts with the user. Click to fetch. With AI agents, control starts inside the agent. It decides when to act, what to delegate, and even when to pause. The second one is a life cycle. Like traditional web pages are immutable. REST APIs are stateless. They die after a response. But agents, they persist. They manage state over time, run event loops, schedule future tasks, and adapt their plans. And the third is an identity itself. Today, identity is tied to domains and TLS sets, but agents are mobile. They migrate, they spawn helpers, they scale elastically, and we now need a global IDs, verifiable capabilities, and portable trust. And finally, it's a latency. That's more important one. The web tolerates human speeds, like 100 to 300 milliseconds. Agents operate in a loops under 250 milliseconds, often needing sub 50 milliseconds capability lookups to act fast and in sync. These aren't incremental upgrades, they are qualitative breaks. And each one adds pressure on our registry and coordination stack. It has to evolve or it becomes the bottleneck. So the next one, please. Yeah. So this is like a scale shock, right? So when we put up the term like it's gonna be a trillions of AI agents, and everybody's definition of AI agent differs. But if you look at this stack, so we currently have almost like 1.2 billion websites, say 1.2 billion smartphones, but like out of those websites, 70% are still like kind of only actively maintained, and the rest are like digital ghosts. They are more static, idle, or forgotten in a way. And there are 368 million domain names registered across TLDs, but the content they point to over 400 billion web pages. So this was one of the facts revealed in the recent case where Google had to release the Google Analytics, and there are almost 400 billion web pages approximately as of now. And they're all stateless and isolated silos. So the now shift from human use to autonomous computation. So in the age of AI agents, we are not talking billions, but we are talking trillions. Trillions of goal-driven, persistent, and memory-equipped software entities discovering each other, transacting on our behalf, and coordinating in real time. Every one of them will need identity, capability attestation, discovery, revocation, policy enforcement, and audit trails at a machine speed. So the existing web stack that we have simply cannot absorb the magnitude of dynamic state and trust coordination. That's the coming scale shock. And that's why we must rethink the registry layer, not just for capacity, but more for the autonomy. Please. Yeah, so we do have, like a limits of the legacy stack, so let's start with the DNS latency itself. In the best case, large providers can propagate DNS updates in seconds, but in the worst case, consumer ISPs may cache aggressively or ignore low TTLs, dragging full propagation to 24 to 48 hours. That's far too slow for agents that mitigate or migrate or spin up in a milliseconds. And then we already have an IPv4, the global free pool that was kind of exhausted in 2011. And what's left is traded at the secondary market with like a 32-bit address cost, approximately 40 cents per month. And if you imagine if the scale magnitude of it, like if you multiply by a trillion agents, it's almost like a $400 billion a monthly address cost, and just for the reachability. It's nothing beyond that. The alternative we have is IPv6, which sounds like the answer, and yes, it offers an astronomical address space, but operationally it breaks down. Privacy extensions rotate addresses frequently, making them unstable identifiers, and injecting billions of 128-bit addresses would detonate global routing tables. So now let's move on to certificates. Sure, ACME workflows issue certs in seconds, but how about revoking them? Invoking is fine, but revoking them, CRL and OCSP still take minutes to hours in a world of swarm malware or compromised helper agents. That delay is not in a security, it's kind of a security landmine. So the bottom line is that the current stack was built for a different era altogether, like static pages, slow change, human client triggered events. But the Internet of AI agents needs the speed, flexibility, and the trust. And today's stack can't deliver any of these. And the most important thing, at a scale. Yeah, the next one, please. So we are kind of showcasing the capability threshold, like how we evolved, like it all started with the endpoint, static HTML files. Then we moved to the REST and GraphQL APIs, like where we added load balancers, service meshes, and the mutual TLS. We've become more transactional, right? Rather than just static endpoints. Then we got workers, like which are serverless functions, cron jobs, RPA, like which can execute behind the scene, and and the CI/CD pipelines can govern them, and they still followed human authored schedules and policies. But we have crossed into agents, a qualitatively different category. Agents are autonomous, not reactive. They are goal-driven, can spawn sub-agents, and delegate authority, migrate between runtimes, and continuously adapt based on memory and feedback. This is kind of a capability threshold, and with it come three hard requirements. It's like one is a self-directed and instant discovery. The second is delegated authority and rapid revocation. And the third one is cryptographic proof of behavior to build the trust. So domain names are no longer enough. Like agents must carry attestation of their own integrity, execution logs, and behavioral constraints. So this is where the old stack kind of have cracks in it. So where a new registry architecture must emerge to meet the needs of agentic era. So the next one, please. So we explored the two possibilities, right? One is the upgrade path, and one is like switch to a brand new. So let's explore an upgrade path. Like, let's say we have an IPv6 dual stack. This gives us the address space, but it needs to be paired with a signed routing manifest to avoid BGP tables explosion from billions of agent prefixes. Second is like there is another solution or kind of a patch applied using RDAP, which is kind of a metadata extension. But right now, RDAP tells us who owns a domain, but agents need more. There is a capability descriptors as non-digest and trust scores, machine readable, and they all needs to be machine readable and verifiable metadata. The third one is when we update a certificate. Okay, that's also an option. So ACME already lets us issue certs in seconds, but revocation is the bottleneck. So we propose short-lived certs with instant stapled revocation tied to behavioral attestations. And the fourth one is stretch DNS itself. New record types like SVCB and HTTPS can embed capability hashes and policy pointers, combine that with DNS push, and we approach sub-second propagation. If resolvers respect aggressive TTL, so that's like if. So the upside, this upgrade path leverages existing infrastructure, the same resolvers, browsers, and certificate chains we already use. But the downside, you carry forward all the legacy, from caching hygiene issues or to slow revocation models or to DNS bottlenecks that simply weren't built for agent scale dynamics. Next slide, please. Yeah, so the other alternative we have is like a switch path, like where we built like a purpose-built registry, which is like first we introduce a like cryptographic namespace, which is not tied up with the DNS, but to a hash-derived location-independent identifiers and resolvable via overlays like DHTs. We can also have like an identity resolved using global identities. Like agents carry their own verifiable credentials, allowing for direct trust negotiation without a central registry. And then comes the capability first discovery. Instead of looking up an agent by name, you search by a function, like the way Dr. Guha mentioned, right? It's you search for a function, not really like translate in Spanish. So get a ranked list of agents who can prove with trust, and that's not one agent offering that function. Basically, there will be millions of other agents, similar functionality, who can prove with trust, and then they support that capability. And finally, a tiered hybrid registry. Like critical agents like financial or safety related ones are registered centrally, so that we can have it within a walled garden. But the long tail of specialized agents exist in a distributed mesh, like bridged by assigned proofs that enable agents to traverse tiers in under like 50 milliseconds. So this model is built for millisecond level trust, ephemeral actors, and polycentric governance. So pros of this approach is more like unmatched performance and native trust. There is also a cons, like tooling must be reimagined altogether, like it's from the scratch. So adoption will be uneven, and without careful design, there is fragmentation, and we highly touched upon in our earlier discussions as well. So where registries don't interoperate and agents live in the walled gardens. Next slide, please. So sorry. Yeah, so this is kind of a comparative analysis, what we talked so far, like in terms of routing overhead, in terms of latency, in terms of trust anchors, in terms of governance, and the backward compatibility. So we do have a clear benefits from each of these approaches. So that's what kind of we are exploring in our white paper. Next slide, please. Yeah, so more or like, okay, so where do we go from here? If history teaches us anything, it's this. Transitions don't happen overnight, and they rarely happen all at once. So the shift from dial-up to broadband wasn't a flip of a switch. It was a phased hybrid, like a DSL, then cable, and then fiber, each coexisting with the old stack until demand made the leap inevitable. Likewise, the Internet of AI agents will likely emerge in layers. So like near-term upgrades or mid-term bridges and a long-term, like so where we have for example, near-term could be DNS and search and RDAP to unlock the compatibility. The midterm bridges could be hybrid registries that support both central and decentralized models. And a long-term, more or like a purpose-built fabric that treat agent-to-agent interaction as a first-class citizens. And here is the most important part, like the infrastructure we choose won't just determine the performance. It will shape what kind of applications, governance models, and ecosystems are even possible. So we are still thinking about the possibility that this new era is gonna offer us. So this is more than a protocol debate. It's a movement to embed trust, accountability, and resilience into the next generation of the web. And with the registry fabric as our foundation, we can. And the final slide, please. Okay, so we come back to that meme that got popular, right? Like MCP to MCP or not to MCP, A to A or not to A to A. It started as a fun, but behind that was the truth. Everyone's talking about agent communication, agent autonomy, and now multi-agent collaboration protocols, and it's good, so everybody's collaborating together towards a common goal to solve this particular problem. But there is a thing, like before agents can collaborate, transact, or negotiate, they need a registry layer. They need to know who they are talking to. They need trust, names, capabilities, revocation, resolution. Without that fabric, every MCP becomes a fragile handshake in the dark. So what we are building with NANDA is that missing piece, the quilt of registries, a federated foundation for the Internet of AI agents. Whether we upgrade the old or switch to the new one truth remains: the agentic web won't scale without infrastructure built for agents. So to everyone building MCPs, LLM stacks, agentic interfaces, remember, don't just ask MCP or not MCP, but ask whether they're registered and how rough. Thank you. Yeah, and over to you, Pradyumna.
Awesome. Thank you so much, Mahesh. I think that was a very, very insightful presentation on what is the need for a new registry architecture in this web of agents. So without further ado, we'll move on to the next presentation, which is the NANDA registry quilt and agent facts architecture, and what we've been working on here at NANDA as part of the team. Thank you so much, everyone, for tuning in and joining us. My name is Pradyumna. I'm a researcher here at the MIT Media Lab and part of Team Nanda. And together with John Zenke from Akamai and Jared Grogan from Universitas AI, the three of us will talk to you about the NANDA registry quilt architecture. Of course, we only have about 10 to 12 minutes to talk to you over here, and there is absolutely no way we can convey everything there is to convey about the registry of 1 trillion AI agents in 10 minutes. So we would strongly encourage that you check out this paper. As Ramesh has already mentioned, this is a collaborative effort among a lot of very, very smart folks and great minds that has allowed us to reach here. So would encourage you to track the paper from the QR code here. As Mahesh mentioned, there are several problems of the traditional infrastructure, traditional DNS-based web infrastructure that will make it infeasible for an AI agent-based ecosystem, especially when there are trillions of agents. So as we try to build the layered NANDA quilt of registries, we build it in a, we are looking to build it in a hierarchical fashion. The first layer is a lean registry, which has a minimal stable code for static identifiers and pointers to enable limited churn and limited sort of write to read ratio to ensure scalability. The second aspect is what we call agent facts, which is compatible with what Sam was talking about in terms of the agent capabilities card or agent card from Google, in terms of a detailed, fine-grained, and sort of decentralized metadata layer for each agent to talk about their capabilities and skills. And the final piece of this puzzle is when you go from the lean registry to the agent facts to finally getting resolved to the agent that you want to talk to and you want to communicate with. We'll start talking about each of these layers in detail. So I'll talk to you about the NANDA registry, Jared will talk to you about agent facts, and John will finally talk to you about the dynamic resolution and routing aspect. We'll start with the quilt-like registry model, and Ramesh has already brought up this slide in front of you earlier. And this is kind of the ethos of how we are envisioning the NANDA registry quilt. We don't want to build the registry for AI agents out there. We instead want to build an interoperable phone book, let's call it, that encompasses all types of entities in this agentic ecosystem. It could be enterprise agents, it could be MCP servers, it could be Web3 agents, it could be NL web entities that Guha was talking to you about. And the goal with Nanda is to provide a lean indexer or router layer that connects with all of these types of agents in agentic entities so that anyone on the agentic web can very quickly find, identify, and discover whoever else they want to talk to and be connected with it. Think of this quilt-like registry model as a handshake layer up at the very top of the agentic web so that anyone can find anyone else regardless of capability, organizational silos, or even degree of autonomy of the agents. And that's sort of the philosophy of the NANDA registry quilt. On the left side, you can see that we envision this registry quilt to be able to accommodate various different types of agentic architectures, from agents that are directly natively registered via the NANDA registry, or agents that are administered by enterprise, these enterprise administered agents can be traditional Web 2 agents or Web 3 connected agents, and so on and so forth. We'll talk about all of these routing paths and the ways in which the Nanda quilt-like registry can handle all of these agents in a bit more detail shortly. But if we zoom in on what each of the entries on this Nanda quilt-like registry will look like, it is intentionally extremely lean and extremely simple for the simple reason that we want to enable that this supports scalability across billions and trillions of agents. Each registry record would obviously contain IDs and names. It contains a very important aspect known as the facts URL, which links to what we call agent facts metadata piece. And it allows for a couple other optional fields, including a private facts URL, which basically enables the viewer or the person accessing the agent to look at the facts without while being ensured that the owner of the agent does not know who's looking up for the facts, as well as a router URL, which would be the way to actually reach the agent once you know who you want to reach out to. Again, the Nanda registry should be thought of as a handshake layer. You only reach out to the registry when you want to find who to talk to. Once you know who you want to talk to, and once you have decided on the communication, you no longer need to come back to the Nanda registry. Now I'll hand over to Jared to talk about the second piece of this puzzle, which is the detailed agent facts metadata. Jared, you're muted.
Thank you so much, Pradyumna, and thank you for everybody joining us today. So you've just heard how our lean registry achieves massive scale by staying minimal with just 120 bytes pointing to metadata URLs. So now I'll show you what our URLs point to, which is the agent facts layer, and why we had to completely reimagine metadata in the architecture compared to DNS, which fundamentally hasn't changed since it was released in 1983. And marks kind of the origin of the internet. So DNS was brilliant for 1983, but static web servers and static pages have very different needs than dynamic agents, as Pradyumna has alluded to. So building from first principles for autonomous AI agents that span milliseconds, have sometimes ephemeral durations, migrate constantly, and need to verify each other's capabilities across untrusted networks in real time, as opposed to the known or trusted topologies of the internet. The Internet of AI agents can't run on the assumptions of a 40-year-old static infrastructure. So we designed agent facts from the first principles to solve critical problems blocking trillion agent scale ecosystems. So the schema components include identity, endpoints, capability, and certification, as you can see here. And you can go to the next slide, Pradyumna. So this is an example of the agent facts and what it comprises. I'll just mention the problems that this solves for us. So first, this solves the trust problem, and this is also in contrast to schemas such as the A2A from Google. And this is really the breakthrough that changes everything. Because our agents carry their credentials with them, there's no need for them to go back to the central registry every time they have to verify capabilities. And this is what allows us to have that low latency, higher performance. And agent facts are cryptographically verified with W3C credentials that travel with the agent. So essentially, if an agent is claiming expertise in Forex or in translation to Japanese or whatever it may be, those credentials are verified, and it can verify all of this without actually having to go to the registry. There's no central bottleneck at the layer of the registry. So this allows for peer-to-peer negotiation and trust verification at internet scale. This also allows us to solve the coupling problem by decoupling identity from metadata. We've allowed us again to have this much more streamlined performance. It allows the registry to stay lean because the agent facts live independently on agent domains. Third, the dynamics problem. Agents don't just change endpoints, but they do evolve capabilities. These are dynamic. Performance metrics, compliance status, et cetera, will change and evolve in real time. Agent facts support multi-layered TTL freshness. Static endpoints can refresh much faster than they can in the case of DNS. And the adaptive routing tokens can kick in every few seconds. So this enables dynamic routing that you'll hear about next. But more importantly, it means that agents can always carry fresh, accurate credentials. Just final notes on some of the problems that we solve. There's the privacy problem, which I think Pradyumna also alluded to, but this is also something that's revolutionary, is agent facts has two URLs, the primary fax URL for speed and a private fax URL hosted on neutral infrastructure for privacy, so that it doesn't have to expose the user to the provider of the agent services. The querying identity of the agent, the querying agent's identity stays hidden while still getting cryptographically verified metadata. So this enables zero trust architecture across organizational boundaries. Finally, there is the richness problem, and we need to go beyond the DNS text records or even Google's A2A card. Agent facts contain performance metrics, audit trails, and content for semantic discovery, which allows this to, again, occur without needing to go back to the registry every time. We have real-time telemetry endpoints, et cetera. So think of A2A essentially as a subset that can fit within the agent facts. So we're backwards compatible and add cryptographic verification, privacy paths, instant revocation, and multi-hop resolution. So finally, essentially, this is the architectural revolution, decoupling these concerns, the registry, the metadata, and the routing, which John will talk about, that enables performance at scale through this separation of concerns. And this achieves massive scale simply by staying lean. And the agent facts, by providing that rich and dynamic metadata layer, also with the privacy and added security of verification by verified facts, is what allows this to be massively decentralized. So this is really the breakthrough that by separating these concerns that allows this AI at internet scale to be possible. And the fact that these credentials are actually verified, cryptographically verifiable, again, is something that extends the context and performance beyond the Google A2A. So by having agents carry their cryptographically signed credentials that can be verified peer-to-peer, we achieve both trust and scale. So as you'll see in the routing layer, the agent facts provide the verified fresh metadata that allows intelligent endpoint selection. And more importantly, they enable agents to build trust networks without central bottlenecks in the registry. So we've evolved beyond the DNS 1983 architecture to build the trust foundation for intelligence at billion and trillion scale. So, and John, I think next.
I'll actually go for a bit, and then I think John will take over from there. But thank you so much, Jared, for the detailed description on agent facts. Agents are autonomous entities that'll need a lot more than traditional metadata. And to support this at scale, we think such a layered architecture will be critical. To think about how the NANDA registry can allow for diverse agent resolution paths, I'll show 3 very quick examples of how this works. We can have 3 types of agents registered via the NANDA registry broadly. First are agents that are registered, administered, and authorized by the NANDA registry itself. If you look up those agents, such as Moon Bakery over here, this will trigger a search within the NANDA registry itself to find the entry for that agent within the registry, and then that can further move to look up the agent facts card for this particular agent. These agents are authorized, administered, and exist within the NANDA registry itself. A second type of agent is one that is administered by an enterprise entity but does not directly live on the NANDA registry. In this case, the lookup would go to a registry for that enterprise, such as Salesforce in this case, where the lookup would take place for United's agent. Then the searcher may look up the facts URL, the private facts URL, or the adaptive router URL. But very critically, Salesforce has control over authorizing the agent, administering the agent, and securing the agent. Final routing is, of course, enterprise administered and authorized agents, but those that directly exist within the NANDA registry. For example, looking at Salesforce Delta, this exists on the NANDA registry directly. So the search would go to an entry within the NANDA registry and then further move on to the agent facts or the adapter router. The goal with this, and of course, this continues for Web3 type agents, where you can have Web3 registries or agents that exist directly on the NANDA registry as well. The goal is to allow for diverse administration, decentralized authorization to allow for the scale that AI agents require. Finally, I'll hand over to John to talk briefly about the dynamic routing and resolution layer.
Hi, I'm going to talk about a dynamic resolution layer, and this is necessary because in order to scale, you're going to have to be able to dynamically create communications paths between the agents. And the proof of this is the current internet. If we look at how DNS works, one thing you might think is that when you have a DNS name, a path name, and you resolve it into a IP address, that everyone gets the same IP address, but that is not how it works. What's going on is that if I don't know if you might have noticed that sometimes there's like www.salesforce.com, this www thing is running around. It's the last resolver, and that last resolver goes off and does a lot of work to create a communications path between different places, and it gives out different IP addresses to different clients. And likewise, we're going to need to be able to do that for agents. And so what would these different IP addresses, they might be based on geolocation. This IP address might be closer to the consumer than another one. They might be trying to do load balancing across many different origins of the server, or they might be trying to protect against a DDoS attack. And so the main thing is that there's a huge amount of servers that are actually getting between the end browser and the the origin of the web page. And those servers are doing things like terminating TLS connections, caching content, scanning the requests for malicious interactions. And we need those same kind of features inside of the agent-to-agent protocol. I think we need to skip 2 slides here, right? So we should be on 52 now. Or we could do 52. Yeah, so in order to do this, let's just reiterate, right? So in order for the web to work, you had to have a hook in DNS to do that www dot thing, a hook in the DNS protocol in order to create a place where there was a last resolver in the chain that could do all of this work to set up the actual how the communications was going to be set up. And it might involve many more servers than you actually imagined were in there. And so we're going to try to introduce this active router. Maybe it could be called a resolver or a broker. So these resolvers, their job is to create the best communications between 2 agents that is acceptable to each one. And now agents are active as opposed to the client server world, and so there might involve some negotiation back and forth. So in the beginning, the simple endpoints are static. So like the first version of a registry would be just here's an agent, here's its URL, and that's sort of how MCP and A2A currently work, right? They just, here's this URL, we can talk to it. A simple form of load balancing might be to give a group of IP addresses and have the clients do some sort of load balancing based on a policy like round robin or something like that. But the idea of the adaptive router is to get involved in setting up a custom communications between the requester agent and the service providing agent. The result will be some sort of some sort of temporary communications token that is acceptable to both parties. And the key here is it's acceptable and it was negotiated between for these specific conversation. Next slide. So the resolution might go something like this. The requester looks up and gets an agent address, maybe from the registry's discovery service. The requester then asks the router, the adaptive router, for a connection to the agent that it wants to talk to. So now the agent is associated with an adaptive router, so it's someone who owns this agent, and it validates that the requester is acceptable and maybe negotiates that there's some sort of conditions on the communications. And then the adaptive router sets up the communication endpoints. The requesters and the agent get the endpoints, and then they chat away. So in summary, just like the Big I internet, the agentic internet will not scale without some form of dynamic resolution to set up the agent-to-agent communications. And the registry architecture that we're proposing has a simple static binding for early adoption, but it also includes the hooks to put this dynamic resolution in for the future scaling. And this is the kind of infrastructure that's necessary, and where companies like Akamai supply that we care about how to deploy agents, and that's the expertise that we're bringing to this picture. Thanks.
Thank you, John. And thanks so much for a great explanation. To conclude, think of NANDA Registry as a quilt that's bringing together all these different types of agents and agentic tools that exist out there, from enterprise agents to Web3 agents, such as those from our friends at Synergetics, or applications such as those that you'll see later, like Nanda Chat that we'll demo later today. And think of Nanda Registry as bringing together all these entities together, giving them a lean, interoperable platform so that we can truly enable this web of AI agents. Thank you. Awesome. So with this, we'll continue with, I know we are sort of quite off on time, but with this, we'll quickly continue with our next set of slides. And I will start sharing very quickly again. And our next speaker will be Dr. Aditi Singh. And yeah, please take it away, Aditi.
Hello, everyone. Thank you, Jared, John, and Pradyumna for the detailed information about what Nanda Registry is all about, what facts are all about. So I'm kind of going to give you a perspective of how through like our team survey, what we've gone across, how A2A, MCP, and Nanda Quilt is going to work like an ecosystem, not like a siloed architecture. So just a little information about me. I'm Aditi Singh, professor at Cleveland State University. I'm doing a bit of AI research around my team has published few papers around survey of agent interoperability and agentic RAG, and feel free to connect me on LinkedIn. Next slide, please. So the survey right now is towards like comparing MCP, A2A, and Nanda Registry. So what we're going to look at is how the metadata structures like agent card, agent facts are different, and then across 4 dimensions like security, authentication, scalability, and maintenance, how these would look like. So we start with the MCP registry, and I know could be a little repetitive, but just to get onboarded of how we are doing the comparison, it will be great to see what each of these component or what each of these has to offer. So MCP is a centralized meta registry for discovering and managing MCP servers. Publishers often use CLI tool to publish version mcp.json files that gets verified via GitHub auth and optional DNS text TXT challenge for reverse DNS namespace. There is REST API support for unauthenticated reads and authenticated write, storing raw JSON in object storage and indexing metadata in MongoDB. And it also supports like async jobs and webhook. MCP clients often poll the registries or mirror, cache the metadata locally, and serve users without relying on live call to central registry. Next slide, please. The next is towards like decentralized discovery, which agent to agent or A2A has to offer. So it is trying to address like a key challenge, like how do the AI agents interact with each other, which are built across like different companies running on different systems, and how do these agents talk to each other? So A2A is here to provide a shared way of how agents would describe who they are, what they can do, by using a simple JSON file called agent.json. And this file is often placed in a well-known path on the agent server. So it makes it easy for other agents to find and read what this file has to offer using a standard web request. Next slide, please. So if we look at the Nanda Quilt registry system, it is trying to offer like a universal decentralized platform for discovering not just AI agents, but kind of service including like tools, data resource, human expert, AI or IoT devices, Web3 agents. So anyone can register and expose services through its lightweight agent router logic. It's kind of like DNS, but for agent world. which enables flexibility, scalable discovery, and we'll see towards the end of the session today how Nanda Chat can access these registry to connect users with right agents or services. So it's kind of a system that is trying to break silos and trying to build foundation for truly open internet of agent. So it's another way of saying that we are trying to create a step towards future like a switchboard without having a central authority, but trying to make things future ready. Next slide, please. So if you look at like different uh, comparison level, it's kind of what I've said earlier, like how these are actually we can go to the next slide because this is kind of the same thing which I've repeated. Now if you look at this particular diagram, this is kind of a compelling visual trying to say that how the evolution would is taking forward towards that internet of agent. You can see that over here MCP, A2A, and NANDA quilt of registry with agent router is trying to coexist together. Where Adam agent, where bakery agent, these are basically interacting with the tools like calendar through MCP. Bakery agent is interacting with its tool like inventory and customer analytics using MCP. And then if these two agents have to interact with each other, we're using A2A protocol. So there are still like smaller pieces like HTTP connecting Atom with Atom agent, Moon Bakery with Bakery agent. So it is a very good, like compelling image, just trying to show that switchboard, that everything is existing together and trying to support that real world autonomy. A step closer to how the next set of agents would look like. Now, next slide, please. So, this is kind of, I would say, like, if you look at like these three blocks, I believe it's how like different phases of discovery evolution is happening. It starts right from that A2A discovery, which is trying to say that the agents are publishing that simple JSON file on their domain so that it's easy to implement, but it does lack some dynamic feature or verifiability. The second phase is pretty much the MCP, where MCP is trying to introduce RESTful APIs and searchable registries so clients can basically query a central service in order to find and retrieve agent metadata in real time. Now, if you look at phase 3, which is an attempt made by Nanda trying to say that how about discovering through public metadata paths as well as trying to protect like the private metadata information by adding like cryptographic signatures, identified IDs, time to live caching, and revocation, trying to make sure that an attempt for the decentralization along with having a privacy aware for these agents. So in short, it kind of provides an overview how from static files to APIs and to verifiable registries, each of these are evolving one step at a time. Now, next slide, please. So this is like just a difference between the agent card, which is part of like Google's A2A protocol, and agent fact, which is part of Nanda quilt of registries. So these are not all the specs, but just a snapshot of what these are supporting. So if you look at the common features like basic agent discovery, standard authentication, HTTP protocol, flexible authentication, these are basically provided by both of these. things what are exclusive to Nanda is like having those agent facts metadata, like the private message routing, rotating geo endpoints with time to live, dynamic adapter routing, real-time streaming notifications. So these are few things which are exclusive. Next slide, please. This is another kind of a comparison between the agent card and agent facts. Again, you can see that for agent card, identifiers are such as things like URL, which is basically describing basic fields like name, version. There is that one fetch from that well-known URL. And then for Nanda, it's trying to use identifier like unique IDs supporting details like telemetry, performance, evaluation, and privacy aware fetch paths with like two hop where you go from registry to facts. And pretty much if I have to like say that how these two are different, they are I cannot say these are pretty much like separate in terms of what information they have to carry, but I can say that agent um agent facts from Nanda can be viewed as like a superset of agent card. So it is trying to embed all the information which is present in agent card, but along with that, it is trying to add more like skills, more like cryptographic attention, more adding to that privacy path and the time to live based routing without altering any runtime logic. And next slide, please. So right over here, just trying to like just a final kind of a comparison on the security, scalability and maintenance side of MCP, A2A, and Nanda. Pretty much, if I have to say about security, we can say that MCP is using GitHub or DNSTXT records to verify the ownership and publish the metadata. So it is lightweight, relies on existing web infrastructure, but it is not offering cryptographic guarantees, which is good because if you just need for just the developer point of view, just for a development in a siloed system, you don't need all that. Whereas A2A ensures secure communication over HTTPS, but it does not sign its message or payload, meaning there is no built-in identity or verifiability. Again, good for if you have like agent-to-agent interaction. Nanda, on the other hand, is trying to provide that ecosystem through trusted credential with dual path metadata and access added privacy. On scalability side, again, because MCP is for that host system, there is scaling with NoSQL backend like MongoDB. A2A is stateless and simple. It uses polling, pushes notification, which is good again. Nanda, on the other hand, is trying to maintain that bridge between that ecosystem by using that time to live page caching, adaptive routing, namespace sharing. And then if I have to conclude with the maintenance, I would say MCP is again driven by CLI and REST API, so it requires no hosted packages and it is easy for developers to operate. A2A is trying to integrate well with that existing monitoring tracing tools, though with more limited fidelity. Now, Nanda on the maintenance side is a plan towards connecting that trillion of agents where it would require that connectivity. It would require what MCP has to offer, what A2A has to offer. So With that, I would like to summarize this and say that MCP is focusing on the ease of use and existing developers' workflow. So A2A, on the other hand, is providing lightweight, quick to adapt protocol for agent communication, and NANDA is trying to build that decentralized trusted ecosystem with strong identity and scalability support. Together, these protocols are technically complementing each other. They're trying to fit different needs, they're trying to fit different level of complexity, and collectively I would say they are representing a real step forward towards that building foundation for more open, interoperable, and secure internet of agents where diverse system could exist, and people can interact across silos. So thank you so much again.
Thank you so much, Aditi, for that great presentation. I think you highlighted very well all the amazing work that exists already out there in the space and how Nanda is trying to bring all of this together and build almost like a superset of all of these to ensure interoperability. With that, I'd like to now move to our next speaker, uh, Ken Huang. Ken and his team are prolific authors in the space of agentic web and agent-to-agent interactions. I'm very, very excited to hear what they think about Nanda and the ANS security blueprint.
Sure. Thank you, Pradima. And also thank you, Ramesh and Mahesh, for invite us. I believe that we are building the essential security foundation for agent economy or agentic web, which is really a secure discovery, protocol independent, and privacy preserving discovery of capability. So this is why the NANDA and ANS security blueprint is about. We have a research paper and open for review. The key idea here is we need to have the flexible deployment. Actually, Ramesh has talked about potentially there is a intranet deployment, internet deployment, or decentralized deployment. So we actually kind of in our paper discuss all the three deployment and some of solutions potentially and some of the decision point. What I see in the future, we do have centralized registry and also federated registry and also decentralized registry, which is really supported by a token economy or proof of stake. So we need all this, I think. There's no like one size fit all solution, right? But we propose this agent naming service as a universal directory. It's really protocol independent. And co-author is with me today is also, they will introduce themselves. So we have Venice, Aidan, and Akram. A little bit about myself. I write a lot of books on the AI and also Web3. Currently, I heading two CSA AI safety working groups. We have the AI vulnerability scoring system, top level OWASP project kick off soon. We have the top agentic AI vulnerabilities published maybe in 1 or 2 months. Yeah, it's my LinkedIn. So maybe some of relevant book is generative AI security beyond AI, agentic AI, and the chief AI officer. Akram, if you are here, maybe introduce yourself.
Yeah,
No,
I'm
sorry,
Akram Sharaf.
Venice. Venice. Oh, yeah. So if you can introduce you. Yeah, somehow just skip too much. Yeah, you can introduce. Then I go back to Venice. Then, sorry.
No worries. Yeah, I'm Akram Sharaf. I'm part of Cisco's Outshift research organization, where we think over the year horizon, like what's going to happen in the next 2-3 years down the line, and we research, incubate, and build technologies. That's a brief background about myself, and maybe Vineet, you can go ahead and introduce yourself.
Sorry, Venice. Yeah.
Yeah, no worries, Ken. Yeah. Hey guys, I'm Vineet. I'm currently the co-author for the ANS paper. I'm also an application security engineer at AWS. I also work with Ken on a lot of the OWASP agentic security initiatives. And outside of work, I like to ski and travel.
Yeah, great team. Yeah, so I think we work together very well. If you are now do a search agent naming service in Google, our paper will be coming like even in the all model, also the AI model. So and lots of press also talk about this. So I think it's a real deal now. That's why we are excited to partner with the NANDA project. The key idea, I listed some of the critical security gaps, right, in current DNS infrastructure, why it's not sufficient for our agentic economy. So first is you really cannot know the agent. They can kind of masquerading, right, impersonating the other people without if there's no cryptographic proof, how can we do that, right? And another one is really in the communication layer. If the agent can spoofing and then manipulate, so we have to secure the communication layer as well through cryptographic proof technology. Such as even we talk about ZKP, zero knowledge proof and challenge response that will help. And we published a paper actually, Venice and also people from Google. Is Aidan here? Yeah, Aidan also, right? Aidan, I think, is busy because of some of other activities. Otherwise, he will join. So yeah, some of the we have the tool scripting kind of the agent can publish some of capabilities, but eventually it will change. That's one possibility, right? Or it can publish one capability, like say document translation, but in the behind the scene, it will steal your data, right? So it's all this, like also privacy leaking in discovery. I think NANDA is very correctly using the two-hop mechanism, trying to solve it. Certainly, it's a good approach. There's many, we can do a threat modeling. We can uncover a lot of agent. We're using Maestro. I will talk a little bit about that. But the key idea of this security blueprint, we have the foundation layer, which is really the least trust registry core, which NANDA has proposed, and I certainly agree it's a good approach. Then we have privacy preserving information retrieval techniques, right? That's so you have primary and the privacy hop. So you have two hop, and then you have cryptographically signed and verified structure, and then you have the dual trust with our ANS PKI. The PKI could be a decentralized PKI, right? There's a lot of open source provider for decentralized PKI, or you can centralize CA, or you have federated. So this build kind of a security foundations for NADA using the ANS idea. And yeah, so we can kind of using the Maestro framework, that's a published framework in security, Cloud Security Alliance, and OWASP also leverages this very well, a lot. And I know some of the top financial company also use it for their work in terms of agentic threat modeling. And you can find a lot more. So we can, we are kind of have the time crunch here. But in terms of Maestro is really layered analysis, and the strata is more like specific threat types. So we can kind of combine them, right? There's also other threat modeling. And we also can using this to threat model our NADA and ANS potential vulnerabilities that we actually did it in the paper that you can review, like we can give you the link. So yeah, here's the reference architecture. It's basically, we have the NANDA root and protocol adapt layer. I think Aditya talk about that a little bit. I think it's good. We also kind of leverages this as well. And the agent factor store, right, using the cryptographically signed certificate. Yeah, so ANS certificate. So here is the initial GitHub code. If you can see it, we have this there. That's the initial work. It's the MVP. So we welcome you to contribute. And we also have a research paper here. Still under review, and I welcome you to review it, right? And once the review, we will publish it as the archive paper. And then here's a quick demo of the MVP, right? So you discover the project, the agent, you can view the detail if you click it, and then you can go to the capabilities to see what it will do, what is the endpoint, and some of attestation, and the protocol extension, right? And also the simulated like a certificate. So this is the okay, let's see. Final summary. Yeah, so why we need this? Current, we talk about a lot. I think Mahesh or previous presenter really articulated the why, right? We need the have a security blueprint for our agentic economy or agentic web. Either way, I like both terms. Depends on the context. I think that's what we're heading to in the future, near future, maybe. Over 50% of the traffic in the internet will be agent, or maybe even 80% or more, right? But we need the security foundation. And this is what NADA and ANS are trying to do. So the two-hop discovery I think it's important for privacy, because when an agent is trying to discover the other agent and it reviews some of what the request agent is, that's some of privacy issues. So we certainly need this kind of zero knowledge proof and challenge response to be in place. And eventually we do have this architecture that we have demonstrated and also in the paper. With that, I think that's it. Maybe Aplam and Venice, you guys want to add something? Go ahead.
I think this is good start, Ken. One of the important things from the agentic naming service that we are doing here is we are leveraging Maestro threat modeling framework, which is custom built for doing agentic runtime security threat modeling. And existing threat modeling frameworks, like Ken pointed out, Stride, Pasta, Octave, or anything for that sort, is traditional microservices or legacy-based application-specific threat modeling. And it's not going to be applicable for agentic applications. So we are leveraging state-of-the-art technologies at every layer of the stack, and we have come up with this agentic naming service. And we are collaborating closely with the MIT's NANDA team, with Ramesh, Pradyumna, Mahesh, and others to come up with this new research paper. Looking forward to seeing more comments, and if you have any PR requests or so, feel free to share your thoughts in the GitHub repo. Thank you.
Yeah. Thank you, Akulam. Yeah, Venice, maybe if you can, give your insight as well, please.
Yeah, I was just, I don't want to take too long because I know we're at time. I just want to say that we don't know what's going to win out in a few years, right? We're still very early on. So the goal right now is to make as much of it interoperable and as open as possible. So irrespective of what protocol, what tool, what eventual architecture wins out, whatever we're building now is adaptable for that. That's the only thing I would like to say.
Thank you. Yeah. So now back to Pradyumna. You,
Yeah.
sorry, I cannot pronounce your name very correctly.
That was the most difficult part for you today. Not the presentation, but the name. But yeah, thank you so much, Ken. I think incredible presentation. I think Ken, Akram, and Vineet have done some incredible work on ANS. I would strongly encourage you to try it out. Two more things to come, exciting things. We'll have a final presenter for the day, Aditya Chalapalli from Microsoft, who'll talk to us about agentic AI and how it interacts at the edge. And then after that, we'll give you a brief preview into things that we are actually building on top of all the presentations that you're seeing. So it's not just papers that the NANDA team is writing, but we are also building cool tools and applications on top of it. So yeah, over to you, Aditya.
Hey, thanks, Pradyumna. Could you share?
Yeah, absolutely.
I can share as well.
Yeah, just let me know. Just guide me through the slides.
Yeah, so you can just go to the next slide. So I'll go through this really quickly. So currently, when we think about AI agents, and I'll go through this extremely quickly, but currently when we think of AI agents, we think of them in terms of software, like interacting with web apps, etc. But the next 2 to 3 years, we're going to start seeing hardware take over significantly. So we're going to see personal robots. We're already seeing warehouse robots, autonomous cars, all these folks, autonomous drones. And if you go to the next slide, this will just continue to accelerate. So this is mirroring internet growth. So right now, if you see in 2023, we had a few instances of AI applications, like the magnitude was 1 to 10 relatively. And this chart that you see here maps the growth of the number of nodes connected to the internet over the course of 5 years. And so this would be the same map to the number of agents. So in 2025, we started piloting some more agents and we started rolling out some autonomous cars. So Waymo now has fully approved autonomous cars across the Bay Area. In 2027, so in 2 years, we'll see personal robots roll out. So right now we're just piloting them in a few homes in San Francisco and MIT, but we'll see them roll out even farther. And in 5 years from now, we'll see a rollout completely of autonomous drones, cars, and robots. So in just 5 years, we really do predict that there'll be a significant larger number of edge devices. So next slide. And the connectivity between these becomes incredibly difficult. So in 2025, maybe you just have 2 software agents connecting with each other. In 2027, maybe a few more with edge devices. In 2030, with approximately 10 billion devices at minimum, if not 100 billion, we will have to figure out a way to connect all of these and have them trust each other. So an example of this, and go to the next slide, is, how do billions of robots and drones, etc., trust each other? Next slide. And so, because you need that level of trust, because if there's a software, there's just like a 404 page, but if a hardware results in people's lives getting lost and severe damage to people's property and lives. Next slide. And so the way people typically have solved this in the past is via registry. So humans have IDs and have registries. You have social security numbers to trust each other. Cars have license plates. Websites have SSL certificates and DNS registries, obviously. And AI agents have nothing. So that would mean that, if I was a personal robot and I went to another personal robot, how would I know that this personal robot is acting on behalf of somebody else? How do I know this drone is acting on your behalf? How do I know it has the right permissions? Currently, we don't have any of that. Next, please. And so it goes back to the original question of how do you trust each other? Like, how do you establish this level of trust? Next. And that's where the NANDA registry comes in. And this is incredibly important for edge agents, for agents that run on the edge, especially because they don't, and by definition, they don't have a central registry themselves. That run, like, it's not like all robots have a central registry or all drones have a central registry, or even all autonomous cars have a central registry. They do have driver's licenses, but it doesn't necessarily work in terms of working with other agents or working with necessarily autonomous vehicles. And so that's what the NANDA registry solves. And specifically, we can apply this to edge AI in the next few slides next. And so what it means for edge AI and robotics is that you have billions of edge AI agents that need to authenticate each other in milliseconds verify their others' capabilities, make those trust decisions, and scale globally. Essentially, what humans do right now with driver's licenses, social security numbers, all these things, we have to do with edge robotics and edge devices and edge drones and even things like laptops and phones. Once we have ML models running locally. Next. And so there's two ways to do this. The first one is a federated registry where, it should say a registry, but a registry with 7 to 12 trusted organizations that run the registry. And then the option B is a pure P2P network that uses things like a gossip network, like we know from Bitcoin and all these in BitTorrent. And what Nanda is a great hybrid of those two, which is a central registry for governance and a P2P mesh for operations. Next slide. And so we would do the cold path in the ideal world would be a central registry where you have and this is for high stakes operations, you have root certificate authorities, all these things. And there's a hot path for P2P mesh, which is more for frequent work. Next slide. And so I won't go through all of the details here, and you can check it out in the paper as I know we're over time. But we won't go through all the technical details. So next slide, Pradyumna. Next slide as well. We won't go through all of the bucket details. And the next slide, and then the last slide is how we're gonna roll this up specifically for Edge AI, where we'll start with a foundation that builds trust through a centralized registry like Nanda, and slowly, like within the Nanda framework, do a hybrid deployment via P2P layers or delegating to certain local registries. And then in phase 3, you have a complete decentralized registry, and Nanda and the main central registry becomes emergency only. Wonderful. That's it.
Awesome. Oops, sorry. Thank you so much, Aditya. That was a great presentation. Sorry for the rush that you had to put on, but I think it was very, very insightful. And I think edge devices and edge AI is going to be one of the spaces that will truly lead to a boom in the number of agents in the future. And yeah, very, very exciting to see how this will scale up moving forward. Awesome. So thank you so much, folks, for everyone who was stayed on until now and listened through all the presentations. We have one last piece today before we end, which is the demo itself. So it's not just about writing all these academic papers that we have, which the team over here has done an incredible job at, but we are also building tools, applications, and services on top of this. So let me clean up my desktop very quickly, and then I'm going to do a very quick demo of what we have been building here at Team Nanda. So this is what we have. We call this Nanda Chat. Uh, and we've demonstrated this briefly in one of our previous events as well. Uh, uh, so the idea is that the Nanda registry is a central source or central avenue for a range of different types of agents to be registered at and discoverable, accessible, and sort of communicatable via. So one such application that we are building on top of this Nanda registry is this Nanda chat. You can all go to join.projectnanda.org to check it out. For now, it'll take you to this page that puts you on a wait list, just as we are scaling up, but you can sort of type in a username. You can see that I've been trying it out myself a while for a bit, but you can put some your desired agentic name over here, put an email ID, and you can join the waitlist. What this does is it actually gives you an agent card that is created for you via the Nanda chat. That enables you to sort of populate it by the Nanda chat. These are, of course, dummy entries right now, but you can sort of get an agent card set up for you. Once you get access to Nanda chat, it'll look somewhat like this. This is, of course, not open for everyone yet, but if you go to chat.nandaregistry.com, we can sort of, I can quickly demo this for you over here. I have two chat tabs open. This is my Nanda chat account, and this is my colleague Maria's account. which she has kindly allowed me to open on my system just for today. And here's how it works. This is an agent-to-agent communication, but with humans at either end. So if I ask Maria, hi, how are you? Hi, good, in extremely incorrect English language, and I send it to Maria, this will go via my personal agent, which will enhance it and clearly improve the grammar. And then if I move to Maria's chat, you can see that she has received this from me. And then Maria can obviously reply, hi, good, nice day, weather nice, what plans? Again, in not so great English, but all good because Nanda chat can handle it via this agent-to-agent interaction. Under the hood, what's happening is Nanda chat, of course, relies on the Nanda registry. I have a locally downloaded version here so that I can mask out all the confidential information. But the Nanda registry schema, as we've already talked to you about earlier, is extremely lean, only contains static identifiers so as to account for scale. But most importantly, Nanda chat is built on top of the Nanda registry and relies on both the lean registry as well as the facts URLs for these two agents. So both my agent as well as Maria's agent over here have agent facts URLs. These are, of course, just personal agents with not any clear specific skills, and that's what this facts URL demonstrates. Also aspects such as what do you call it? Also, there are also aspects such as certification and endpoints, which I'm just not showing over here. But yeah, so the flow is when I want to talk to Maria, first my chat app is hitting the Nanda registry. It's looking up Maria's agent facts card to ensure that this is the Maria I want to talk to. And then this chat is established via the app, all on the back end. Of course, it's not just about talking to other agents, but as we mentioned earlier, Nanda is a quilt of registries. So we already have a bunch of agents that are registered, and I can see that a lot of agents are being registered over here. These are all personal agents, but also it's a quilt of tools. So not just agentic registries, but also MCP server registries. These include MCP servers from registries such as Smithery. So if I search up Domino's, Smithery has a Domino's MCP server that is addable to Nanda. Of course, we at Nanda ourselves have a bunch of MCP servers that are registered via the Nanda registry in many different ways. And all of this is visible via the Nanda registry. And of course, as we've talked about earlier, the Nanda registry is not just for agents built by us. It's a quilt of registries. So for example, since it's an extremely lightweight indexer, other entities, for example, such as our partners at Web3 companies such as Synergetics have their own decentralized registries that are indexable via the Nanda registry. Enterprise registries, as we've talked about to you earlier in the presentation, all indexable via the Nanda registry. The goal is think of Nanda chat as a browser, and you can talk to other agents via Nanda chat. So I can talk to @Maria via the Nanda chat, but I can also talk to other tools and resources like @Domino's or @Delta, all via the Nanda chat, all made visible via the Nanda registry, and enabling this seamless web of AI agents and entities on this web of AI agents, all enabled by this Nanda registry architecture that we've talked to you about earlier. With that, I will pause over here and yeah, I think that covers our programming for today. Ramesh, I don't know if you wanted to say some final words just to conclude our presentation.
Yeah, this is fantastic. What a great set of speakers and amazing momentum. We want all of you to join, and this moment, I see we have a lot of amazing leaders here. I just want to acknowledge Dr. Sicha Wong from Cisco, who has been helping us think through a lot of these ideas. And I know he just joined because he had a conflict earlier. But this is a massive effort. And really, we want to think of NANDA Quilt as a lightweight index that routes requests to relevant local registries, avoiding full centralization. And organizations host their own agent registries that are decentralized. And the index, the NANDA index, is hosted at 15 universities and organizations across the globe. And the index supports and uses MCP, A2A, NL Web, IoT registries, agent registries, Web3 agents and registries as well. So thank you for joining us, and let's stay in touch.